The sky can hide big secrets. A new one has just begun to emerge from the darkness. Russia is developing a new strategic bomber. It is a machine that seems to belong more to science fiction than to today's world. The program is known as PAK, which stands for Prospective Aviation Complex for Long-Range Aviation. Observers and defense experts around the globe are watching every development with intense focus. They are trying to understand what this new aircraft represents. The world is asking what this new bomber will be capable of, and what its existence means for the delicate balance of global power. This is not just another airplane, it is a statement of intent. The first hints of this hidden power came through grainy images and digital renderings. These pictures spread rapidly across defense news websites and social media forums. They showed a radically different kind of aircraft. The plane possessed a sleek, blended form. Its wings were broad, sweeping back, merging seamlessly into a flattened body. No prominent tail fin stood tall. Every line and curve appeared designed to slip through enemy radar. This was the initial shock for many. This aircraft was not an evolution of older Russian bombers. It was a leap into the next generation. The shape of the PAK-DA tells a compelling story of its intended purpose. The aircraft adopts a flying wing design, a concept that has fascinated aeronautical engineers for over a century, but has only become practical with modern computer-aided controls. The smooth flowing surfaces are meticulously crafted to minimize the aircraft's radar cross-section. Sharp angles and vertical surfaces, which are notorious for reflecting radar waves, have been almost entirely eliminated. The engines are expected to be deeply embedded within the aircraft's thick body, a technique used to shield their intense heat from infrared sensors. The wings blend fluidly into the fuselage, another critical feature that helps to scatter and absorb incoming radar signals instead of reflecting them back to their source. This design philosophy clearly borrows from the principles proven by other stealth aircraft. However, the Russian approach has its own unique characteristics. The PAK-DA is expected to be a very large aircraft, significantly larger than a stealth fighter. This size is a direct consequence of its mission requirements. It must carry a heavy arsenal of weapons and a massive amount of fuel to achieve intercontinental range. Therefore, the designers face a constant balancing act. They must optimize the aircraft for stealth, while also ensuring it can carry a meaningful payload over vast distances. At the core of any aircraft, especially a strategic bomber, lie its engines. The engines of the PAK-DA are its heart, providing the power needed to push its massive frame across continents. They must be a marvel of engineering, delivering immense thrust while also being incredibly fuel efficient. These engines must also be designed with stealth in mind. A conventional jet engine produces an enormous amount of heat, creating a bright signature that is easily detectable by infrared sensors. To counter this, the PAK-DA's engines are likely to feature advanced cooling systems and shielded exhaust nozzles that mix hot exhaust gases with cooler air to reduce their thermal footprint. The development of such sophisticated engines is one of the most challenging aspects of the entire program. It requires breakthroughs in materials science to create turbine blades that can withstand extreme temperatures and pressures. Extensive and rigorous testing is necessary to ensure their reliability over thousands of flight hours. The power generated by these engines is not just for propulsion, it also supports the aircraft's complex suite of onboard electronics, sensors, and flight control systems. Clues from early models and official statements suggest the use of a derivative of the Kuznetsov NK-32 engine, the same powerhouse used on the Tu-160, but heavily modified for subsonic efficiency and low observability. This represents a pragmatic approach, building upon proven technology while adapting it for a new stealthy platform. A true intercontinental bomber must be able to fly thousands of miles, strike a target, and return to base, all without landing. While aerial refueling can extend its reach, a large internal fuel capacity is paramount. This allows the bomber to operate with greater autonomy and to launch its weapons from standoff distances. A bomber is ultimately defined by the weapons it carries. Its primary armament will likely be long-range cruise missiles. Stealth technology is not a magical cloak of invisibility. It is a collection of advanced techniques designed to delay and deny detection by an adversary. The primary goal is to drastically reduce the aircraft's radar cross-section, which is the measure of how visible it is to radar. The PAK-DA's flying wing shape is the first and most important layer of this defense. Its blended surfaces and lack of vertical stabilizers are designed to deflect radar waves away from the receiver rather than reflect them back. Leading edges are aligned to specific angles to control reflections, creating a directional spike the bomber can point away from threats. The second layer involves materials, radar-absorbent coatings with ferrite and carbon that convert radar energy into tiny amounts of heat. Even the cockpit canopy uses thin films of gold and indium tin oxide to prevent radar from bouncing off helmets and equipment inside. Designers bury engines and use flattened nozzles to mix exhaust with cold air and reduce the infrared signature. Some concepts even cool the leading edges heated by airflow, helping the aircraft blend with the background temperature of the sky. Counter-stealth systems, low-frequency radars, passive sensor networks, and multi-static receivers can raise detection odds, so stealth is paired with smart tactics, avoiding radar sites, flying at night or in adverse weather, and employing electronic warfare. The introduction of a new strategic stealth bomber like the PAK-DA is more than technological achievement. It is a significant move on the global geopolitical chessboard. When a major power unveils such a capability, it sends a powerful message to both its allies and its rivals. For Russia, it signals recommitment to top-tier power, capable of projecting force anywhere on Earth and maintaining a credible deterrent. Others reassess defenses, investing in early warning radars, space-based sensors, and next-generation interceptors to counter low observable threats. Arms control grows harder. Verifying cruise missiles inside stealth bombers is far tougher than counting visible weapons on older jets. Developing a cutting-edge aircraft like the PAK-DA is an incredibly long, expensive, and difficult process. From simulations and wind tunnels to engine and avionics labs, years of R&D precede the first metal cut. Prototypes are painstakingly assembled as heavily instrumented flying laboratories. Engines run, controls cycle, and electronics are powered and checked. Test pilots then expand the envelope, speed, altitude, maneuverability, and measure stealth on specialized ranges. Problems arise, engines underperform, software glitches appear, components wear. Each sends engineers back to the drawing board. If successful, full-rate production begins. Behind the imposing hardware lies the critical human element. A small elite crew endures 20-hour missions across time zones, in radio silence to maintain stealth. On the ground, planners choreograph routes, weather windows, and threats, giving the crew the best chance of success. Programs like this inspire pride but demand resources, sparking debates about budgets, priorities, and the true cost of security. Abroad, they raise fears of a new arms race and increased instability, requiring clearer explanations from leaders. The emergence of PAK-DA reminds us warfare constantly evolves, away from brute force and towards stealth, precision, and information. Its flying wing design, advanced engines, and capacity for next-gen weapons point to a new era of air power. We must parse facts from speculation as testing and deployment reveal true capabilities. Impact depends on doctrine, crew skill, and political choices. Remaining unseen may matter more than speed. Reach will be measured in keystrokes and flight hours.